Everyone. In last class, we had started with IoT enabling technology. In that, we saw two things, which were those wireless sensor network, and also we saw cloud computing. That is how to use wireless sensor network with IoT, and how to use cloud computing with IoT, and which are the different things we can give it for rent. That is on the cloud, like infrastructure, platform, or software. So today we will continue with the same, that is IoT enabling technology. 5 were there, 2 we completed, 3 more are there. So let's we'll see today those 3 which were remaining. Is PPT visible? Yes. So today we will be continuing with chapter 1, session 10. Okay, so of the first chapter, that is IoT enabling technology. PPT you are able to see, no? Yes or no?
Yes, ma'am.
Oh.
Yes, ma'am.
So last class we saw wireless sensor network and cloud computing. Today we will continue IoT enabling technology such as big data analytics, communication network, and embedded system. So do you have any idea what is big data analytics? Yes. What is this big data and what is this analytics? Do you have any idea? Yes. So this big data is nothing but lots of data. Earlier we had limited amount of data and which we could store in the form of structure, that is in database. Data DBMS we used when we had very less data. But now lot of data is generated. Many people are using many online systems, and analyzing those data will help the people. So they are doing this analysis on this lots of data, and for this big data analytics we cannot use your this structured database. So next is communication protocol. So for IoT, we need also something called communication protocol. That is for helping the things in IoT, this network. We need something called communication protocol, which will help the two things to communicate with each other. We saw IoT protocols also, right? Same thing will be same. Then last one is embedded system. Any idea what is this embedded system means? Yes? Any idea you have embedded system means? Earlier, before IO, yes, anyone wants to tell something? So earlier, when this, what is it? IoT was not there. There was something called embedded system. Okay, this E&C people are still doing this, wherein hardware will be more and software part will be less. Okay, you can mute yourself if you don't want to tell anything. So hardware part was more, whereas software part was very limited. So those were embedded system, like your washing machine or your car. Hardware part is more, right, than software. In washing machine, small program is there. As washing machines are advancing, you're getting more and more automation because more and more program. Same thing in your cars. Yes or no? So embedded system means hardware part will be more, software part will be less. So these three we will be discussing today in today's class. So this is big data analytics. Okay. So before we'll see about this, what is this big data analytics? I'll show you a video, then I will go through this thing.
Available in the world today has been created over the last 2 years. We find ourselves in the age of big data. But what does this mean exactly? Big data analytics is the study of huge amounts of stored data in order to extract behavior patterns. These data are characterized by the high speed they are being generated with, the huge volume they represent, the immense variety of typologies they encompass, and the degree of veracity they own. More than 2.5 trillion bytes of information are generated every day through our smartphones, tablets, GPS devices, sensors spread all over our cities, bank cards. What can be done with all this information? This is where big data analytics comes into play, a combination of high technology systems and mathematics, which together are capable of analyzing all that information and providing it with a meaning of great value for companies or governments. There are four types of big data.
So this was about big data. Big data means lots of data is there. Characteristic also you saw. Speed will be more, then velocity, volume, lots of data will be there. Now we will see how they analyze. Okay, these are the types of big data analytics.
Data analytics. The descriptive one explains what happened in the past based on data presented through graphics or reports, but not why or what will happen in the future. The diagnostic one, closely linked to the previous type, seeks to understand the reasons why any given event took place in the past. The predictive one, the most useful for companies, goes through data in order to predict what could happen. And finally, the prescriptive one, an evolution of the preceding approach based on automation processing or A/B testing. This system, besides analyzing and predicting data, advises on how to proceed according to them by recommending, for example, the best location on your site to place a banner or the most convenient gas station along your way if you want to avoid traffic. Big data analytics helps companies or public administrations to understand their users better, find previously unnoticeable opportunities, provide a better service, and even mitigate fraud. The revolution of datafication is just beginning.
So just I showed you a video, okay, which will tell you about big data. Big data analytics means lots of data. It has some characteristics. So only data is not sufficient. What we require, what we have to do, we have to analyze. So they have told you four types of analytics. Okay, first knowing seeing the data, we can find out the patterns. Okay, so that is known as descriptive. Then we have prescriptive, predictive, and also we have something called diagnostic analytics. That is not there for your syllabus. Just I showed a video, so you'll get a better idea. So we'll see what's there for your syllabus. Okay. So this big data is defined as collection of data set whose volume, velocity, or variety will be large. Okay. So what is there? It has a collection of big data is collection of data set. So half thing is missing here. Okay. Volume, velocity, or variety will be very large in big data. And this big data involves several steps, that is to analyze. Big data is different, analysis is different. Big data means lots of data, whereas analytics means use this data and analyze and to come to a conclusion. Like I have a small part of data, your result sheet. So I have to analyze, and then might be I can predict what will happen in coming exam, or so on. Okay. So big data involves several steps starting from data cleansing, data munging, data processing, and visualization. Okay. So data cleansing in the sense we'll get lot of data. We don't need all those. So we will clear it, filter it out. Then data munging means trying to understand which data might be helpful for me. Then processing that data, and then afterwards, after processing, I'll get some graphs or something for visualization to understand what is happening. Okay. Then for this example is weather monitoring data, health and fitness data, location and tracking of vehicle inventory. So all these things which all we have studied application, no? All places we can use big data analytics. So this is very important. There are three characteristics of big data. In the video it was four, but for your syllabus they have written three, so you have to write three only. Okay. So first one is volume, second is velocity, and third is variety. So volume in the big data, what will happen? Volume means size. Okay. So how much it will be? In big data means lots of data will be there. So it is very difficult to store, manage, and process using database. Since in database you had already database. If you have very less amount of data and you know how much data is you have to store, you can use this database. But in big data, what will happen? Randomly, anyhow, it will be not generated structurally. Maybe you will take some customer data from Twitter, some from his Facebook account, from some from his online shopping account. All those data you have to club and come to a conclusion. So we cannot store it in traditional database. Okay. Second is velocity. Velocity of data refers how fast the data is generated and how frequently it varies. That is, volume is lots, this size. Velocity means how fast it is generated. See now only, if you're using Instagram account, so many people will be there. How much data is getting generated? Yes or no? Or Facebook. So many people, whenever they're free, they'll just click and upload so many things. Using that data, so many things we can understand about that person. Okay. So velocity means how fast the data is generated and how frequently it varies. Okay. Modern IT, industrial and other system are generating data at increasingly higher speed. So very fast, lots of data is coming at a very this fast velocity. Velocity means speed. Okay. Volume means size. Velocity means speed. Third one is variety. Okay. So in database, what would happen? You would get only this one form of data. For example, in DBMS, if you have an employee database and you would write name, salary, okay, his SSN, only those data would come here. And maybe if you have to fix some data type in DBMS, maybe name means varchar, only character type of data would come. But here in big data, variety refers to forms of data, and so in big data, you will not get the same type of data. Okay. Again, big data might be structured or unstructured. Structured is some data which can be stored in database. Okay. Whereas unstructured is which cannot be stored in database. So the data can be text, okay, text data, image, audio, video, or sensor data. So these are the characteristics of big data. So one is volume. Volume and size. Lots of data will be there. Velocity is speed. Variety is this. What is it? Uh, type of data. So you can use different type of data. That is, you will have different type of data in big data. Different variety, image, audio, video, or sensor data. Okay. So any doubts in big data analytics? This is one of the IoT enabling technology. Next we'll see communication protocol. So you know communication protocol helps in the IoT system, because without communication protocols, what would happen? Yes, you could, so many things were there in IoT network, okay, and everyone had its own language or own protocol to speak, then they would not work like a system. Okay. So this is very important. So what does communication protocol helps in? It allows device to exchange data over the network. For the devices to exchange the data over the network, communication protocol is required. Okay. And this communication protocol defines the data exchange format, data encoding, addressing schemes, all those things we had studied in communication protocol, right? That is how data exchange formats are defined, how encoding is done, decoding is done, addressing scheme. We studied IPv4, IPv6, yes or no, low WPAN, those all we studied, and how the routing will happen. Yes, routing different transport kind of protocols are there, TCP is there, UDP is there. So all those things are defined by a communication protocol. Other function of protocol includes sequence control. Sequence control means when you have a bigger message, you will divide it into smaller things. So when you divide it into smaller things at the receiver side, okay, maybe I have a message, hi, how are you? Okay, maybe I'm just giving an example. This is not a big message, and it is cut and it is sent through the this, what is that, communication this mm, cables. So there what is happening at the receiver? At the receiver, same speed, sorry, same sequence, it has to be arranged. Otherwise, it will be first U might be delivered, then R, then high. Okay, so the message, the sequence has to be, sequence number should be there for the message, and at the receiver, based on the number, the receiver will rearrange the message. Then flow control, that is sender and receiver should be synchronized at the same speed. Okay, one is slow, one is fast, then there will be drop in packet and retransmission of lost packet. So only this much is there about communication protocol. Already we have studied in the starting of the chapter different layers of IoT protocols. Okay, and what which are the different protocols that can be used in each layer. All those things are there. Next comes embedded system. So what is this embedded system? Yes, it is a computer system that has computer hardware and software to perform the specific task. It is like IoT only, but in IoT, hardware will be less, software will be more. Whereas in embedded system, okay, computer hardware will be this very much, and software will be just a small part of it. ENC students will be doing, no, that is what they are doing. So key component of an embedded system is microprocessor or a microcontroller on which they program. Then memory, networking units, IO units, and storage. Same like IoT only, but they'll be having microprocessor mainly. In IoT, we will have mini computer. Okay, and they have their own operating system also. Like for our laptops and all, we use Windows, Linux, no? And here this embedded system will have their own embedded operating system that is known as real-time OS or RTOS. Real-time OS, this embedded system uses. Embedded system will range from low cost miniature device such as digital watches to devices such as digital camera. Okay, so these embedded system will be very small in size. Okay, so these are some of the examples for that. Any doubts you have in embedded system? So we will see one video about the embedded system, then continue.
What exactly it means, then you have come to the right place. In this video, I will show you what embedded systems are and what are the forms they come in. Are you ready? So let's begin. Wide variety of sizes and performance, and hence are big large requirements. Let's try to get a basic understanding of what an embedded system is and how to classify them. A simple definition would be an embedded system is a special purpose computer, custom built to serve a specific purpose. Let me put an example. A calculator is a special purpose computer as compared to a
So calculator can be an embedded system.
To understand that, let's first look at the other end of the spectrum, which is general purpose computers. General purpose computers are those that we use every day, like desktops, laptops, and Macs. Even our smartphones and tablets are more towards the general purpose end of the spectrum, which means they have more than one specific purpose. For example, even though the smartphone's main purpose is communication through emails, text, voice, and videos, they are designed for other purposes like hearing songs, listening. My favorite taking purpose computers are very specific to serve a particular function.
So this your embedded system will have special purpose computers
It's one
there.
and purpose computer a need of come in different flavors. The embedded systems can be broadly classified into three categories: subsystems, standalone systems, network systems. Let's first look at the class of the embedded system known as embedded subsystems. The term embedded means placed inside something bigger. This flavor of embedded system is usually a part of a larger system. In fact, this is from where the term embedded system was originally coined. A popular example includes a digital dashboard. The car is the larger system and the display is embedded inside. Other examples include the timing and display circuit for microcontrollers, washing machines, and
So these all are part of embedded system, okay, which are connected to internet. It will become IoT. But this currently your washing machine, okay, small panel is there to control, or your micro oven like this you have now, or your car dashboard. All these form a part of embedded system.
even part of a computer like keyboard and a mouse are basically embedded systems. Independently, these embedded systems are useless, but they aid the larger system to do their task. Next, let's have a look at another class of embedded systems, called as standalone embedded systems. What are standalone embedded systems? It's a device that can perform its function independently, as an express. Examples include USB drivers, which are used to store data, microcontrollers, which handle logic, and cameras, which take pictures, and display functions, which process time. Although they are not embedded in something bigger, the components used and the techniques used to build these systems belong to the same class. Here, several sensors are placed throughout your code, and they collect the query to perform an order. This is the latest trend in this field, and more products
Here we can use
this
IoT.
class of embedded system, which combine electronics, programming, and networking all together. This type of system is popularly known as the Internet of Things, or IoT for short. If you would like to learn more about embedded,
Okay, so that is what embedded system means. More hardware will be there, less software will be there. Okay, and these days this embedded system have come which will to work with IoT system, and in IoT system software part will be more. Okay, so in this class we studied about big data analytics, communication protocol, and embedded system. So there is one question. Explain this. What is it? IoT enabling technology in your textbook. Okay, in your question bank, you have to write about three things. One is cloud computing, wireless sensor network, big data analytics, communication protocol, and embedded system. So let's see some of the questions to see how well you have studied. Okay, what are the three V's of big data analytics? Can anyone tell? What were the three we studied? What were the characteristics of big data analytics? Which were those?
Velocity, volume,
Value, velocity, and
Yeah, volume, velocity, and variety. What are the different features of big data analytics? What all it will do? What all we can do? Large amount of data we can collect, large variety of data we can collect. Okay, and all these can be analyzed to know the better understanding we will get. We can predict already what is going to happen based on this big data analytics. Next, big data analytics involves, yes, analysis of large amount of data you can write. Sequence control in the communication protocol deals with, what does sequence control do? Yes, what does sequence control do? If a larger message is there, we can divide it into smaller and transmit. But while transmitting, each one will be given a sequence number. At the receiver side, based on that sequence number, the divided message can be rearranged and the receiver can read the message. Next, communication protocol allows, it helps in what? Helps It allows in communication between things in a IoT network. Then RTOS stands for what
Real
does
time OS.
yes, real time
Real-time
OS.
abroad.
Okay. So that was for the today. Any doubt you have? Yes. So we have completed the IoT enabling technology. So any other doubt you have? Yes.
No, ma'am.
No. So tomorrow at 10 only I'll start. I'll not start early. So do your assignments. And some people were asking about quiz. Quiz. This is today's 10th session. Okay. So after 2 sessions, that is after 11th and 12th session, this chapter will get over. That time I'll keep the quiz. Okay. After each chapter, I'll keep a assessment quiz. Okay. So see you tomorrow. Have a nice day. Bye.